Hello everyone, I welcome you all for the video lecture. In this video, we will discuss Stack ADT. What is a stack? A stack is a linear data structure which follows last in, first out principle. The element inserted last is the first element to be removed in a stack. Example, we insert an element at the top of the stack called push, and we remove an element which is the top of the stack, which is called pop operation. Empathize phase. Why do we need a stack? When we go into this, there were questions like, how do we organize items that are accessed in reverse order? Where do we encounter last used, first removed situations? Why can't every problem be solved using arrays or queues? So thus come the need for a data structure which uses the principle last in, first out. In real life, we are experiencing examples like stack of plates and stack of books. And we can give real-time examples like browser back button, function call, undo redo operations in editors. And this define phase. Let us define what is a stack ADT. So after the empathize phase, we thus evolved to the concept called stack, and we can define it as linear data structure that stores element according to the last in, first out principle. The key characteristics are linear data structure, which follows LIFO ordering. It is actually performing operations like insertion, deletion, which is occurring at the top. And it is efficient for push and pop operations, which is of the order of 1. And operations at the top only. The operations push, pop, peak is accessing the top element, and we can check whether the stack is empty using isEmpty function, and we can return the number of elements by using the size operation. And stack representation. This is how the stack can be represented. Whenever we push an element into a stack, it is inserted at the top of the stack, and whenever we want to delete an element, we use the operation pop to remove the top element from the stack. So where we use this concept is, as already discussed, it is used to stack a pile of plates. In browsers, back button is a real-time example for stack, and the undo and redo operations that are performed is using stack, and the stack of books example. And another example we can give is function call, which is recursively called. In idiot phase, how can we represent and use a stack? Let us brainstorm different approaches. Visual stack diagram helps understand the LIFO order clearly. Then the stack of plates demonstration is a real-life example to relate the LIFO concept. Then the animation of push and pop. The push operation is used to insert an element at the top of the stack, and pop operation is used to remove the top element from stack. Interactive animation to visualize operations, and Possible applications of stack is expression evaluation, parenthesis matching, depth first search traversal, browser history, undo redo operations. Stack ADT, which uses last in first out principle. The last element inserted into the stack is the first element to be removed. So here, the operations performed are push, which is insert, insertion operation, which adds a new element at the top of the stack, and remove operation, which removes the element from the top of the stack. So all the operations push, pop, peek are performed only at the top of the stack. Real-time examples where do we use stacks? Stack of plates, stack of books, browser backbutton, function calls. Whenever a function is called, it is pushed onto the stack, and when it returns, it is popped from the stack. Undo or redo operations in editors in Word documents. There we use stack concept to do the operations, and box stacking in another example. The common property is last item placed as the first while removed. Stack data structure is a linear data structure that follows last in first out principle. Can define stack as a collection of elements in which insertion and deletion operations are performed only at one end called top. The characteristics of stack are it follows LIFO principle. Insertion and deletion at one end, that is the top element. Then the last inserted element is removed first. Top keeps track of the topmost element. It is dynamic in nature. Basic operations are push, pop, peep, is empty, is full. Push, insert an element onto the stack, and pop, remove the element, which is the top element, and peek, return the top element without removing it. It is empty, check if the stack is empty. It is full is checking the stack is full or not. We use it in syntax checking, backtracking, undo operations in editors, expression evaluation, function call management. Then the advantages include it is simple to implement, efficient memory usage, useful in many applications, and it follows natural working order in many tasks. Stations balances. Having limited access, that is when the top element is accessed, and then overflow possible in array implementation, and if possible when stack is empty. So we have discussed the push, pop, peek is empty size operations. So here we have illustrated with a diagram. The push operation is inserting an element, which is adding an element to the top of the stack, and pop, which is removing the top element, and peek is to view the top element without removing it, and is empty is checking whether the stack is empty or not to perform pop operation, and the size, the number of elements that we can check using the size function. Thus coming to the end of the session. Thank you.